Alright, adding and subtracting can be the more difficult operations when it comes to sig figs. In multiplication, it's really simple. You simply count the number of sig figs, and your answer has the same number of sig figs as your least number of sig figs in the numbers you're multiplying or dividing. In addition and subtraction, the situation is much more complex. The answer to an addition or subtraction of two measurements is only limited by the least place value they have in common. For example, I want to add these two numbers. According to my sig fig rule, when it comes to addition and subtraction, I have to find the least place value they have in common. In this scenario, the last place value they have in common is the tenths place. So my last sig fig on the left is going to be located there. On my right, my numbers can extend infinitely. There's nothing to prevent me from creating increasingly larger numbers going to the right. For example, here we look, the last place value they have in common on the right is the tenths. However, when I add them together, I get 122.3. So their last place value is the tenths, so my answer would be 122.3 meters. And you're saying, wait a second, neither of the two numbers I added together had 4 sig figs, so how did I wind up with 4 sig figs in my answer? How does this addition and subtraction rule make any sense? It has to do with what we're doing when we add and subtract measurements. The easiest way to think about it is a common household ruler. You've seen a ruler before, you've used a ruler before. I could take that ruler, and by laying it end to end to end to end to end, I could measure the length of the Eiffel Tower, right? I can measure increasingly larger things using that ruler simply by adding it, right? That means when I use a measuring tool, there's no upper limit. In terms of going to the right, there's no limit. However, think about that household ruler. Could I take that household ruler and measure the length of a human hair? No, I couldn't, right? I couldn't use that household ruler to measure the width of a human hair. It can't measure something smaller. Therefore, if I have a measuring device capable of measuring 34343 microns, or micrometers, and I want to, I shouldn't have said microns and micrometers are different units, but anyway, 3.34 micrometers, and I have another measuring device that measures something but can only measure to 1/10 of a micron, could I really say that the total measurement was 6.6434 micrometers? No, I couldn't, right? Because this measuring device doesn't provide any information about that. The same way you can't use a ruler to measure the width of a human hair. Therefore, when you're adding and subtracting, it's going to be that last place value they have in common, or the least amount of precision your instrument gave you, that's going to determine your sig figs. Specifically, if we look at a couple examples here, these were a couple emailed to me by a student. I have 8.990 minus 8.930. Now, in this case, they both have the same number of decimal places, so their least place value is the same right there. So I'm going to subtract. I get a 0 there, I get a 0 there, and I get a 6 there, and a 0 there. Therefore, my answer, even though both numbers had 4 sig figs, right? 4 sig figs there, 4 sig figs there, my answer winds up only having 2 sig figs. right? Only those two numbers are significant. If we were going to write it in scientific notation, we'd write it like that, because we're just getting rid of our insignificant zeros. These zeros are insignificant because they're before a non-zero number in a number with a decimal. So adding and subtracting can create sig figs, and it can destroy them, essentially, because of the nature of what you're doing. Let's take a look at another. Oh, zeros after a number are significant, so that's why that last zero there is significant. Let's take a look at another example. This time we're going to add those same two numbers. Once again, I look at the least decimal place they have in common, right there. So that's going to be the leftward boundary for my number of sig figs. My sig figs can go infinitely in that direction. So I'm adding them together. So my answer, with my correct number of sig figs, would be 17.910. And yes, I started off with a number with 4 sig figs and a number with 4 sig figs, and I wound up with an answer with 5 sig figs. Why? Because I can use the ruler to measure the height of the Eiffel Tower, but I can't use the width of a human hair. With sig figs and addition and subtraction, you're limited to the left. You're limited to the left, but on the right, you can go infinitely, right? You can increase your number of sig figs to the right infinitely when you're adding and subtracting, but you're limited on the left. All right, let's see if I've got any more questions here on sig figs. One more.